This is the Automation World Get Your Questions Answered podcast, where we connect with industry experts to get the answers you need about industrial automation technologies. This podcast series is sponsored by Allied Electronics and Automation, carrying the most automation and control brand names in North America. Now, the questions posed in this podcast series all come from automation technology users like yourself across the process and discrete manufacturing industries. I'm David Greenfield, Director of Content for Automation World, and the question we'll be answering in this episode is how to select IoT sensors for industrial applications. Now, to answer this reader question, we're speaking today with Allan Hottovy, Industrial Automation Training Development Manager with Schneider Electric's Telemecanique Sensors, which supplies a variety of sensors ranging from presence and position sensors to gas and liquid pressure sensors to related Internet of Things technologies for those sensors. So, with that, Allan, let's start with the basics. What differentiates an IoT sensor from a traditional one?
Thanks, Dave. I really appreciate Automation World inviting me to this podcast to answer these questions. I've been using sensors for about 30 years, and in my mind, a traditional sensor is basically an analog sensor that can only convert the physical element, stress, force, temperature, into an electrical signal, and then that signal is fed into some type of recorder or device that'll analyze the test. You know, I remember a long time ago we'd do a test, and the post-test analysis was just a real pain, took an extreme amount of manpower, and was really expensive. One of the big benefits of the IoT-enabled sensors is it eliminates these post-test labor costs because they have a brain and they have the ability to communicate to a big brain. And so, because of this, and their ability to perform automation calibration, they can monitor and collect information on the system's health. It all adds up to decreased operational costs. I think the biggest difference is that the information is collected and analyzed and extracted. A lot of different valuable data is extracted from this, and that is really the true power of the modern IoT sensor, is the ability to record, analyze, and make decisions, which the old traditional sensors had very limited capabilities of doing that.
There are, of course, as I said in the introduction, there's many types of different sensors, temperature, pressure, flow, proximity, image, etc. Is
Mhm.
there anything about the IoT enablement of these kinds of sensors that impacts their basic functions beyond, the communication aspects you were talking about that would affect their function positively or negatively? Or is it just, as you were saying, is the IoT enablement of a sensor simply a matter of its data collection and transmission capabilities?
The data collection and transmission is very, very important, but it all is about the size of the data bundle you're pushing back. And so one of the big things with the smart that you put inside the IoT sensors is you can do real-time analysis at the source and reduce the data. So you get decreased setup times because they got self-calibration and other self-identification features. It used to be a real challenge to hook up like 300 sensors on a network and then figuring out which sensor was what. And the IoT, industrial Internet of Things, has the ability to do that self-identification stuff. The speed and the analysis of the decision making is much, much faster. That's one of the big benefits on it. You can do a lot more processing in real time embedded in the sensor, depending on what type of intelligence it has. Um, Many times there's high level control and diagnostic features, maybe pattern matching, or they're taking a vibration signal, a dynamic vibration signal, and calculating the velocity RMS signal and sending that out. So this data reduction and bundling of the data to smaller sizes is a really important feature, and especially when you're trying to get the information out and make decisions of it. Um, Another big important aspect of it is being able to collect and analyze not only the sensor's health, but because you got these sensors out all the time, you can also get a good indication on what the health of the process or the machine or the environment or a whole bunch of other type stuff. So this health monitoring and things like that is really, really important. Another thing that I like is the ability to adjust in real time for real time conditions. So if some event happens and you need to reset things up, you got that capability built into the sensors a lot. Um, I think when you really think about it, the biggest positive is that when you hook up to the internet and you get these things talking like that, you're really only limited by the creativity of the people using them, and so it just opens up so many avenues of development and uh, increase in profit and a whole bunch of things because of all this fundamental processing, storage, and analysis capabilities are embedded in these systems. When I look at the negatives, I think the biggest thing is just that, the more complex something is, the harder it is to troubleshoot and support. And when I go out in the field, that's the number one thing is it's just the technology is kind of overwhelming the ability for a lot of the maintenance guys to sit through and support it. And that's going to be a continuous issue because it's really hard to find talent. The security threat, when you hook it up to the World Wide Web, the potential security threat's always going to be there. There's really no way to get rid of it unless you isolate. Um, I found that when I get systems up and running and we got them all bugged out, about a year or two later, you get somebody that comes in and does a software firmware change, and the capability or the connection structure changes when that firmware updates. That's been a continuous problem of, well, I got this machine that's there for 30 years. How do I keep it updated with the communication when I got all these updates coming all the time? And that one, I tell you, I think from a control point of view, that one really gets us frustrated with the IT department. Um, I run into problems at home and after about 4 o'clock, 6 o'clock at night with just bandwidth, with all the uncontrolled growth of the internet traffic. It's really outpacing the ability to keep up with it, and that's I think it's going to be a concern. And infrastructure development is going to be an important part to keep this growing. Recent VPN access changes and security changes in our company and other things it's become kind of excessive and complex. And I know a lot of the field guys are starting to grumble about the problems we're having just keeping connected. And you come down to this fundamental thing: when you got billions of access points, how do you keep it secure? It's all about the security. I think is probably the biggest negative. You got all this stuff connected. How do you keep it secure? And that's going to be a constant battle.
Okay, and a couple of times you've referred to the embedded intelligence in these various sensors. Can you explain a little more on that? Is that embedded in the chips in these sensors? Is it embedded operating software in these? A combination of the two? Can you just explain what this embedded intelligence is?
I've seen all kinds of stuff. You can either do like from our mechanical a limit switch for pressure. We have a spring in there that will only send a signal out when the pressure gets to 60 psi to turn the pump off, and then it'll send another signal out when the pressure drops to 40. Sometimes the embedded intelligence could be just a spring that's set for a trip point. You take it to the next level. You want to do like you taking the overall values. We do a lot of stuff where voltage sensors and power meters and things like that are looking at the efficiency and current draw during the process and looking at repeatability and studies and things like that. So having that type of embedded intelligence where you take the sensor up to the next level, maybe doing a filtered RMS conversion of a vibration data to look at the bearing condition is like one where you start with 40,000 bits of information and you convert it down to one, one eight 16-bit value, on it. And that type of embedded ability is all over. Even with the machine safety equipment, there's a lot of diagnostics and stuff that has to make sure that the system's working right. That's an embedded type intelligence you need to do a functional safety solution. So you're always going to have that need for that local, unrestricted, fast control, and embedded in that intelligence locally in the IoT system is the best way to do it. It takes bandwidth away from the network. So if you get the data down smaller, you can communicate faster, you can process stuff faster, you can respond faster, and that's all the keys to doing process control. You gotta do it one thing in, one thing out. So that speed's all embedded in there too. It's all over the map. The imagination, you're going to find everything, and it's different industries will do different types of that type of processing. It all depends on what value they're trying to get out of their signal.
And you mentioned bandwidth a couple of times here
Hmm.
in the discussion, and obviously, as you're talking about at home, the bandwidth issues we're all facing, at peak times. But how does that play out in
Yep.
industry? Are there steps that line designers or engineers in plants should be thinking about as they deploy these sensors so that they don't negatively impact operations from a bandwidth perspective?
It becomes just a basic number crunching and your bandwidth. Each signal has a certain amount of upper end speed, and when you total all them together, you want to make sure it's just like the current going into your house. You want a 200 amp load. You want to make sure you stay underneath that uh, signal. And when you get the open systems with the consumer market, it's really hard to control that because you don't know who's hooking up what. But when you're in a factory and they got a secure, closed system with the real restrictions on who's getting in and out of the VPN network, you can sit there and do a lot better job with the bandwidth. You can go fiber optic, you can put the right modern high speed equipment in the plant. And typically, most of my problems is not inside the plant. It's when I try to get outside the plant and get to that open network,
Mm.
issue. And that could be a real challenge. Like right now, I'm in a valley in Tennessee, and the only internet they have here is copper wire coming in.
Mm. Okay.
So no fiber optic capability. So there's also that physical. What part of the world you are. If you're in a city, you probably got a lot of options. If you're out in the country, may not be as many.
Okay, thanks for clarifying those 2 points. I just wanted to make sure everybody was all on the same page. Now, because IoT applications, obviously, they vary widely from industry to industry and application to application. What are some of the key considerations regarding IoT sensors that users should be aware of to ensure that the sensors they're looking at or evaluating for their industry, whether it's discrete manufacturing, batch or hybrid, or continuous processing, to make sure that those are well suited for their application?
That's a great question. It's very important to understand what type of housing you need to put around the sensor elements in order to survive the environment. And one of the things I really like about the global and the North America rules, like the North American NEMA or the global EN 60529 or the IEC 529 egress protection. A lot of people call them the IP codes. These ratings come in really handy when you're asking these type of questions because they rate the sensor body's ability to survive a particular environment. As an example, I had a gentleman that wanted to put a inductive proximity sensor underwater for a boat lift. It had to be 1 feet underwater, about a foot and a half to 2 foot underwater all the time. He decided to use an IP68 rating because it's designed to be submerged underwater up to 1 meter for an indefinite long time. Another customer of mine had a pressure switch in the basement of a house. A NEMA 1 was just enough. Open housing, didn't have to worry about it. The only thing they had to do is protect bugs and stuff from getting inside of it so they didn't foul out the points. So if you either use the NEMA or the IP specs and learn how to use them and then match them up with the environment, so you got that number, IP 65, 68, 69K, or a NEMA 1, 4, or 8, or whatever, and just follow them, that's the best way to go. It's international, they're well thought out, they're documented well, and it's a standard that you can believe in. You know, I just tell people to use the one they're most comfortable with, NEMA in North America or the IP stuff if it's more of a global approach.
Okay. It's nice to know with something with all the new things everybody's having to get up to speed with, that this is at least one area they can rely on the tried and true and well known factors that they're familiar with.
Absolutely, that's what they're for.
So the main point, as we've been discussing, of IoT capable sensors, is really all about getting data from production equipment to the edge or to the cloud for collection, storage, analysis. However you're using it. But given that, what are the most important data transmission or connectivity features of IoT sensors that users should be most conscious of when they're assessing IoT sensors for their applications?
As I've been told over and over again by countless managers, cost, cost, cost. It's
Mhm.
like, we started out like 30 years ago. When we were doing uh, structural testing on space components, space shuttle components, stuff like that. We targeted like $3,000 a channel as the total installation cost. Now that price has dropped to well under 100. On it, and so I think when you look at that cost, it's reducing labor costs, reducing communication costs, and the size, processing, all that's involved. So I look at the pricing, and then I look at the ability for the sensor to perform self-identification and calibration of the system. This reduces my setup time. That's really important. If you got 6,000 channels out there, it's really hard to line all them up. So that self-identification and calibration feature is something that really comes in valuable for big systems. um, Being able to analyze and putting like a brain locally, or maybe you got it in the PLC, sensor feeding the PLC locally, and it's doing some like a high speed counter or pattern matching for X versus Y plot, like for a force versus displacement quality control curve or stuff like that. Being able to do that higher level analysis and reducing the data to a good or bad value that can be transmitted up is another important feature that can really help with bandwidth, communications, and things like that. I highly recommend sticking with a standard that they're very well comfortable with, they've used, they've had a lot of experience with. Some of the new stuff that doesn't have a history, you got to remember this stuff is going to go in for 20 to 30 or 40 years. So the new stuff, you don't know if it's going to be around 20 or 30 years from now. So sometimes you got to think about that. Like, do I try something new or do I stick to something that I know is going to be around for a while? And I think that's the obsolete stuff can come up and bite you if you don't have that support. And a lot of programs I've seen have gotten bit by that 10 or 15 years down the line, on it. I do not like proprietary, one of a kind, or stuff that's creating a lot of market buzz right off the start. That tends to not be a good thing for a process engineer to work with. We want reliable, robust, tried and proven systems that I can put out there and forget for 20 years. And that's never going to change. And it's something we are constantly in conflict with the IT guys because they want the newest and greatest, and stuff flips a lot faster.
Yeah.
That's something that causes a lot of frustration with people. I think the fundamental thing, remember, this is capital equipment. It's designed for decades of work, and the transmission system that you use has to be supported for the same time frame. And that's going to be a real challenge. I got files now that I've stored that are 10 years old. I can't even open them,
Mm.
because I can't get access to the data. And so I think, when you set these systems up, it's important to understand the initial thing, but you got to really spend some time thinking about the long term life all the way to when you take it offline, and make sure you look at all the situations, and you have a path that you can actually travel from the birth to the death of that project.
One more thing, staying on the data transmission and connectivity features of the sensors, what about wired versus wireless transmission protocols, ranging from wireless HART to IO Link wireless and their relation to IoT sensor connectivity capabilities? Is there anything specific users should be aware of in terms of the whole wired versus wireless sensor discussion?
I think they got to first be open to, in most situations, you may need both. You just got to be open. You can't kind of just, I'm going to do wired or wireless, because you're going to get into weird situations. One's going to be better than the other. I follow some kind of guidelines. I use wireless mainly when wiring is hard. I got really long leads, or some other issue. Maybe I got a vent up on top of a roof, or a truck door coming in. I just got one sensor up on the top to tell when the door's all the way open. That's a really nice wireless because the cost savings. You don't have to run the conduit, the cable. Get somebody. It just makes it a lot simpler. On it. I prefer hardwired systems because the signal's more secure. It's harder to hack. I get a stronger, cleaner signal to work with. I don't have to worry about like a truck or somebody moving a pallet in front of the transmitter and all of a sudden I lose it. It's just there's a lot of things that can occur in an environment when you're starting to shoot a signal through the air. They can interfere with that signal to get into the place you're going at. I'm not a big fan of putting wireless everywhere because of this. Just it's just so easy to get into wireless because when you put it in the air, everybody has access. When you stick it in a wire, you got to physically get into the wire. And security, that really helps. And so I'm going to probably stick with wired and use wireless only when I need it. And that's pretty much the philosophy I've been following for the last 5 to 10 years.
Okay. Yeah, you mentioned security there, and you had mentioned it a little bit earlier in our discussion as well. So, kind of focusing on that, on the security aspects of IoT sensors, since that's with anything IoT related, that's the big concern because it is connected, whether it's wired or wireless. Are there specific security factors that you recommend that users keep in mind as they're going through their IoT sensor selection process, or is security really more handled at the network or controller levels? How does that shake out?
I think it's got to be a team effort on security. You got to do the local guys, the network guys. Everybody's got to be working together it's complicated. It's hard. A lot of times you don't even know what's all connected to the internet, because people put devices or they bring some gadget in and stick it in the plant someplace and stuff. So I think, you got to stick with fundamental ideas. Always have a good reason to connect to the internet that provides a clear benefit or need. I mean, you got to have a specific problem. Don't just put an iPhone app on a refrigerator, but you got to have a reason for it. Something that really can pay for it. It's a definite benefit. Predictive maintenance, so I can pick up a bearing and determine it's going to fail before it actually fails to get a guy in there to look at it. That's a really good reason to do it. And so think about it. Make sure it's a clear benefit and make sure it's a clear need. Every new connection is another access point that someone can target. So you got to kind of keep that in mind. So when you build these systems, security's got to be your number one thing to think about, and then go in and get the equipment on it. I just like to ask the question: just because you can connect it to the World Wide Web, is it a good thing for your company? Be overly cautious in the design, fully isolate and totally control access to the space whenever possible. You're going to get a lot of different ways to do this, but if you stick with the tried and proven standards, you stick with stuff that's well thought out, it has a very robust multi-path security check. So maybe I log in with a PIN number, and then I got to do a bio check or some other thing, a different type of check to keep that security really high. You cannot do the single check anymore. It's got to be a second or third with a completely independent path, because that makes it almost impossible to hack. So as long as you do that second or maybe third check, I could see that coming in another few years, and do them passes just like machine safety equipment. If somebody's going to die, you got to have at least two different ways to detect that error, to protect them. And I think you got to kind of take that same philosophy into the security of the IoT things. Is double path the security, make it very robust, control the access points, and really get rigid about all this wireless stuff. We come and make sure you understand what's going into the system and keep control of that. It's hard. It's going to be a challenge, but it can be done.
Well, thank you for joining me for this podcast, Allan. And thanks to all of our listeners. And please keep watching this space for more installments of Automation World Get Your Questions Answered. And remember to visit our website at www.automationworld.com to stay on top of the latest industrial automation technology insights, trends, and news.